Hello, Mr. Fry's Algebra 1B class. This is April 12th. This is not due until the 15th. I know you were taking some notes in class. If you need help with those notes, just look to Mr. Fry's notes. They should be done for you, and we're doing them in class. If you're zooming in on those, that's great. That'll explain them, but they are done for you in his notes. So if you look in his notes, you can find those. This was an assignment that was posted today. It's not due until the 15th, like I said, on Thursday. So I want to take you through most of it. It says, number one, which of the exponential functions below show growth and which show decay? Remember, whatever is with the x exponent, whatever is right there with it, if it is 1 or above 1, it's going to be growth. If it is less than 1, like a decimal, it is decay. Got to be careful if it's a fraction. That fraction could be an improper fraction and it could still be growth because that improper fraction could be greater than 1. I don't have any fractions in this one, but I just thought I'd tell you that. 1.3, that is more than 1, so that's growth. 0.8, that is less than 1, so that's decay. 1 plus this amount, so that would be 1.025, and so that's growth because it's more than 1. 1 minus this amount, think of $1 minus 40 cents, you'd have 60 cents, so actually this is 0.6 in here in parentheses with that x, so that would be decay. All right, to give you a little bit of help in number 2, I'm not going to show you each answer. I want you to work on some of these, but to get you started, since January 1980, the population of the city of Brownville has grown according to mathematical model y equals 720,500 times 1.022 in parentheses to the x power, where x is the number of years since January 1980. Okay, so explain what the numbers, that number and that number, the 1.022, represent in this model. Remember, from your notes today, that this is the formula for exponential growth. This amount that's before the parentheses is the initial amount, so that should tell you an answer for A. For this letter A, okay, what one of those is. And what is in here, what's in parentheses, is that growth rate, okay? And then what the x is, they label it as t here is the time, okay? And then answer a couple of the other questions regarding that information, but that really helps for A. Number 3, a population of 800 beetles is growing each month at a rate of 5%. So write an equation that expresses the number of beetles at time x. So 800 times, that's my initial, and then here's the growth rate, 1 plus 0.05, and then you have the value of x, which would be the time. This is the growth rate, this is the time. About how many beetles will there be in 8 months? You just put an 8 up there. It's about, because it comes out to a decimal, 1,182. And I thought of it differently when I was working out, 5% of 800 is 40. Why don't they just take, that 40 and multiply by 8 and then add that to the 800? Well, that's all based on the 800. See, it's 5% each time. So each time it builds, it exponentially grows. So that's why you have to use the exponential growth formula for that. Because the other one comes out less than that. Okay, number 4, and I just want to set this one up. The half-life of a medication is the amount of time for half of the drug to be eliminated from the body. The half-life of Advil or ibuprofen is represented by the equation R equals M times 0.5 with time divided by 2, where R is the amount of Advil remaining in the body, and M is the initial dosage, and T is the time in hours. So, letter A, a 200 milligram dosage of Advil is taken at 1 p.m. How many milligrams of the medication will remain in the body at 6 p.m.? So you're just going to set this up like this. And it's 5 hours because between 1 and 6 is 5 hours. And then for this one, if a 200 milligram dosage of Advil is taken, how many milligrams of the medication will remain in the body after 12 hours? And this is what you would put in your calculator: 200 times the quantity of 0.5 N quantity times 12 divided by 2 or 6. And you would figure out that one. So I set those two up for you to lead you right to the answers for number 5. Your new computer costs $1,500, but it depreciates in value by about 18% each year. So write an equation that would indicate the value of the computer after X years. So depreciation, you're going to have Y equals A and 1 minus R, and we have the T there. So it will be Y equals 1,500 in parentheses, that's Y minus 0.18, and then the end parentheses and the X exponent. So how much will your computer be worth in 6 years? So in 6 years, it would be about $456.01. About how long will it take your computer to be worth close to $0 according to your equation? It's about 50, and I just put that in Desmos. So if you look here in Desmos, that depreciation comes down and it comes down. It's comes down, starts to hit 0 right about at 50. And if you plug that in your calculator, it actually is like 7 cents or something like that. So that one where it said 6 years, would it be worth? So if we did 6 years, so this is 5 years, 6 years, and we just keep going up. So this was, let me see, this is 10. So 5, 6, let me try to go back like that. Okay, I guess I'd have to go up really high to show you that. What was it? Our answer was 456. So you could see it on Desmos too, just to show you. I'm getting real close. So 6 year right there. That point right there, 6, go back a little bit more, 456.01, just what we got when we worked out the equation, 456.01. So you can see it on Desmos too, pretty cool. All right, good luck with the rest. And if you need any further help, just let me know. Shoot me an email. Thanks.